all knowledge belongs to Allah alone, and we cannot acquire any fragment of this knowledge except by His will. We seek to emulate our Prophet Muhammad sallallahu alaihi wasallam, who was asked to pray for an increase in knowledge. So we also pray to Allah, Rabbi zidni ilma. We do not seek knowledge for fame or for fortune or for winning arguments or for increasing our pride. Rather, we seek knowledge for self-purification, for recognition of the greatness of Allah. We seek knowledge that enters our heart, and we seek knowledge which will allow us to serve the Ummah of the Prophet Muhammad sallallahu alaihi wasallam for the sake of the pleasure of Allah alone. This is lecture 3 of our course, Introduction to Statistics for Muslims. It deals with comparisons as our last lecture. In the previous lecture we saw that comparisons are tricky and depend on meanings. They are not as simple as they appear on the surface. Conventional statistics deals with numbers alone, and our goal in this course is to deal simultaneously with numbers and their meaning. We will carry out statistical procedures and simultaneously understand what these procedures mean in real world terms, and we will see that paying attention to the real world meaning has a very strong impact on the appropriate statistical technique. In this lecture we will deal with some very elementary techniques which are used in making comparisons. These techniques are sorting a list, ranking, percentiles, and basically we will be studying how Excel spreadsheets are used to carry out these procedures. One of the most basic statistical operations is that of making comparisons. Before we start the technical details of this, we would like to review an old story by Sheikh Sadi which contains a lot of wisdom which will be of relevance to us. The story is one which is familiar to most Muslims. There was a young boy who was part of a poor family. His mother could afford to buy him new clothing for Eid, but she was unable to buy him new shoes. So when going towards the Eidgah, the place for the Eid prayers, the boy was feeling very embarrassed because even though he had new shoes, he had new clothes but he did not have new shoes, and he looked at neighbors and friends and relatives with shiny shoes, and he kept feeling ashamed and embarrassed and angry at his parents for not being able to provide him with the new shoes. But as he was walking along, he noticed a boy who was moving along on crutches. He did not have any feet. When he noticed that, he suddenly realized how lucky he was that he had both his feet safe and sound. He had something to put his shoes on. And then he realized that he should be grateful to Allah for the blessings that he has, rather than being ungrateful for what he did not have. Similarly, there is a hadith of the Prophet sallallahu alaihi wasallam that when it comes to matters of the deen, we should look to those people who are more advanced and ahead of us in terms of spirituality and in terms of taqwa and in terms of characteristics pleasing to Allah. When we look to those who have more, then we will be motivated to make greater effort to come closer to Allah. In exactly the same way, we should, when it comes to affairs of the dunya, of the possession of material things, we should look to those people who have less than us. In that way, we will be content with what we have, and we will be grateful to Allah for it. Another hadith says that true contentment is true richness is the contentment of the heart. Conventional statistics is based on a separation between numerical facts and the real world. The statistician is supposed to deal purely with the numerical side, the objective, the technical, the statistical analysis, and the applied person or the field person will deal with the interpretation of these numbers and these statistical facts. As Muslims, we cannot do this separation. We must deal simultaneously with the numerical aspects and their real world interpretation. In order to do this, we need to know the sources of the data, how it was generated, how much imprecision there is, as well as the real world meaning being attached to this data set, and any debates and controversies which surround the use of these numbers in this way. Statistical analysis is profoundly and deeply affected by the real world meaning, and we cannot separate the technical analysis from the real world meanings. There is a duality in the Western theory of knowledge which says that the objective and the subjective are sharply separated, and we can do a purely technical analysis of the numbers without taking into account any controversies regarding the meaning and interpretation. This is simply not true. To illustrate the difference between a purely numerical statistical analysis and a meaningful analysis of the same types of comparisons, let's look at this small set of numbers. As a numerical fact, 460 is bigger than 390. No one can dispute that, and there is nothing really very interesting that follows from this. But if we consider what is being said in this table, that Pakistan had a GNP per capita in constant $2,000 in terms of purchasing power parity exchange rates of $460, whereas China had $390 measured in the same terms, and therefore Pakistan had higher GNP in 1990 than China. Now we are talking about the meaning of this purely numerical fact, and this meaning is subject to a lot of dispute. First of all, we must ask, where did this 460 come from? How was it measured? How accurately was it measured? Did somebody just make up a figure from his head, as often happens in these GNP calculations when there is nothing available? There is a story that in certain countries there was no data available, so the statistician just took the average of the neighboring countries and put in that figure. And this happens quite often when numbers are not available. You find some plausible guess for it and you put that down, and other people start quoting it as an objective fact. So how accurately these numbers were measured, then after these, then there is, as we noted in the last lectures, 3 adjustments have been made. We have adjusted for prices, we have adjusted for currencies, we have adjusted for purchasing power, we have adjusted for the population. All of these adjustments are quite arbitrary. In addition to this, there is the issue of how large is the non-market sector, which has not been measured. And so because of these numbers are highly inaccurate, and one cannot really say for sure. I mean, what we are saying here is that 390 is a guess for measure of wealth of China, and 460 is similarly a guess for the measure of wealth of Pakistan. So it would appear by using educated guesses that Pakistan had a greater income, but we cannot really say for sure. In addition to this, there is a deeper level question which we must be aware of, that does in fact GNP per capita accurately reflect prosperity of the country? On this issue again there is a huge debate, and in fact the current consensus position is that GNP is not a very good measure, and there are certain well-known defects in this measure, and Muslim statistician must be aware of the meanings that are attached to the numbers that he is using, and any debates and controversies which surround these numbers, because his statistical analysis is not a purely objective numerical thing. The statistician must be engaged with the real world and must be aware of how these numbers and how this analysis is going to be used. Next, we are going to look at some basic operations that are required to make comparisons among a list of numbers. So, for example, in this spreadsheet we have the incomes in terms of GNP per capita in 2010 measured in the same terms, that is purchasing power parity constant US $2,000. The countries are arranged in alphabetical order. We have just selected a few countries for the sake of illustration in this chart. Pakistan has the income of 665. Is this a good number or a bad number? That depends on the reference group. Compared to Congo, it's very good. It's better than Bangladesh, but not as good as India's income of 800. This is interesting because in 2000 the comparison was not in the same direction, so apparently India has caught up to Pakistan and gone ahead of it. What has it gotten ahead of? It has a bigger market now when measured in per capita terms, roughly speaking. A bigger measured value of market transactions. Well, to interpret this fact, we need to know what this means. We need to know a lot of things about real numbers, about the reality behind these numbers. Just the fact that 804 is bigger than 665 doesn't really mean very much, and to understand what this number means, we need to know a lot about what has been happening in India, what has been happening in Pakistan, and how these numbers have been measured and what they are supposed to represent. Anyway, the rest of this lecture will be about technical aspects of comparing numbers, the purely statistical and technical side. So here we note that which country has the largest income? Well, after looking at the numbers, you can see that Bermuda with 63,000 has a number which is hugely larger than the next highest, which is 28,000 for UK, and Spain has 15,000, which is higher than Saudi Arabia, and so on. So we can make some comparisons, but it's not so easy, and as we will see, that if we sort the list, we can learn all of the things about the comparisons much more easily, whereas answering the same questions with an unsorted list is difficult. So to ask what is the rank of Pakistan, which countries are richest, which countries are poorest, it can be done with this data, although it becomes more and more difficult when there are larger numbers, and these same questions are much easy much easier after sorting the list. So we will go to sorting the list and what kind of information can be extracted from a sorted list in the next slide. The most important types of human knowledge are those which are acquired by experience. Nobody else can teach it to you. In order to acquire this knowledge, you have to do it yourself, like the driving or swimming or many other things in life. So similarly, one important part of this course is based on acquiring skills in manipulating spreadsheets, and there is a separate module which will be teaching you those skills. What you would need to know at this point is how to search for the World Development Indicators dataset on the internet, how to download it, how to unzip it, how to open the Excel spreadsheet, how to sort it, arrange it, to extract the data that you need to sort it. All of these things will be taught to you separately in labs. In these lectures we will not be covering these aspects. Rather, we will be covering what happens after you do all of this technical work, after you have arranged the data. What do you learn from this? So these are the issues that we will be concentrating on the lectures. The terms that we are going to cover in the remaining part of the lecture are things that happen after you sort the data. You can see what the maximum is, what the minimum is, what the range of the data is. The range is basically the distance between the minimum and the maximum. And also we will be studying the terms of rank and percentile. The WDI dataset, WDI stands for World Development Indicators. It has 246 countries, including groupings of countries like Africa and Middle East and LDCs and so on, OPEC. So from this dataset we eliminated all countries which had missing data in the years of interest. The missing data is sometimes due to the fact that there was no purchasing power parity index available for the country. Sometimes it was due to war in the country which made it impossible to collect information. Also, we have eliminated all groupings, like Europe is a group and Africa is a group and so on. So after all of this elimination, there remain 130 countries. Those are the subject of our analysis. Now in this table, what we have done is we have sorted the countries by their GDP per capita in 2010. This GDP has been adjusted for purchasing power parity, and also it has been converted to a common currency, which is 2005 constant dollars, so inflation adjusted as well. And of course the entire table of 130 figures is too large to display, so here we are displaying the top 7 and the bottom 7. From that we can look at what is the minimum and the maximum, and we can also calculate the range. The range is the distance between the largest observation and the smallest observation. So there are a lot of things that we can learn by looking carefully at this data set. We can see that, for example, Congo has not been doing very well. It had a higher GNP in 1980, and it has been steadily going down. So the poorest country has been growing poorer, even though the world as a whole has been growing richer. So this illustrates the main point that the process of growth does not actually get shared evenly. There is something which is called the trickle-down effect, which says that as the rich get richer, some of this extra wealth will also go to the poor. It doesn't seem to be happening in the world level. If you look at all of the bottom 7 countries, you will see that most of them have been doing very badly. Burundi, Niger, Central African Republic, most of these countries had bigger incomes in 1980 and less 30 years later. So they have actually grown poorer, even though the world as a whole has grown richer. So one of the things that this data set can be used to argue about is that the trickle-down effect doesn't hold, and one of the things which is currently being pushed as the right economic policy is that we should focus on growth, and automatically growth will take care of poverty. It seems quite clear that this is not true, from this data at least. A second issue that is of interest is to look at what has been happening to the range. If we look at the difference between the maximum and the minimum, you can see that it has been going down. It was 123,000 in 80, 122,828 in 80, and it went down to 73, 68 and 68. So it has been going down, although not much change took place between 2000 and 2010. There is something which is called the convergence hypothesis. According to the convergence hypothesis, the incomes of the countries will converge. All of the poor countries will become richer and the rich countries will become poorer, and ultimately all of the countries will have the same income. So from looking at this data, it seems like the convergence hypothesis might be true. At least it seems like the difference between the maximum and the minimum is decreasing, and so superficially the data seems to support the convergence hypothesis. As we will see, this is not true. If we examine the data carefully, we find that the largest incomes are being recorded by the oil producing countries. For example, in 1980, the UAE has an income of 123,000, which is far above and beyond anything else. This is what is called an outlier, a number which is outside the range of the normal data. Similarly, UAE, Brunei, these are very small oil producing countries. They produce a lot of wealth because the oil is very valuable. At the same time, the population is very small. So when you look at the GDP per capita, it becomes very high. So Qatar and Kuwait are also countries which have very high GNP per capita, again for the same reasons. In fact, in 2010, the largest income per capita belonged to Qatar, but the country got eliminated because it had some missing data in 1980. So now when we look at the range of the distance between the maximum and minimum, but we exclude these small oil producing countries which are exceptional and do not follow the pattern of the typical countries, then we get the graph which is displayed on this slide. As you can see, the graph with the outliers included shows a decline and shows that the convergence hypothesis holds until about 1990, but after 1990 there has been no reduction in the spread. The range has remained more or less the same. However, if you look at the countries after removing these 4 countries, which are sort of Middle East oil producing small countries which are outliers, then you get a clear upward trend. The data shows that the range, the spread between the maximum minimum has been increasing slowly, and in the recent past it has increased sharply. So quite the opposite of the convergence hypothesis. The range has been increasing instead of decreasing. The poor countries have been getting poorer and the rich have been getting richer. So now the thing to point out here is that understanding this data set and interpreting it requires having knowledge of the meaning of these numbers. If we pick out these 4 outliers and we see that these are the oil producing countries which have small populations, that's because we know about the real world, and therefore we know that these countries are exceptional. If we don't know about the data, then we cannot reach this conclusion. On a purely numerical basis, we would say that the between up till about 1990 the convergence hypothesis hold, and since 1990 there has not been much change in the range of incomes at least. This would be an analysis based purely on the numbers, but this analysis would be wrong because it doesn't take into account the interpretation of the numbers. So the Western idea, which this course is against, is that we can isolate the two functions. One person can do the statistics, the numerical analysis, and the other person can do the real world interpretation. What we would like to say is that this is not true. We have to be on both sides of the picture. The statistician must know what the data he is analyzing, and he must have an understanding of the meanings of the numbers that he is using. The analysis that we do depends very strongly on the interpretation. A purely numerical analysis is not going to give us good results. So this idea of the fragmentation of knowledge, that a statistician can just juggle numbers without knowing what they mean, and the applied person can utilize the statistical analysis without knowing how it is done, these are both wrong ideas. One needs to in order to do statistical analysis, one must know the meanings of the numbers that are being studied. For some purposes of statistical analysis, it is more useful to look at the ranking of the countries rather than the GDP numbers themselves. Now, rankings are things which the students are very familiar with because they are always being ranked. So the first ranked countries is the number 1. So here we have converted all the GDP information into ranks. In 2010, since the data was sorted according to 2010, so the ranks are in perfect order. There are a total of 130 countries, and Congo is at rank 130, which means it's at the bottom. Liberia is 129, and the rankings increase in sequence. If you go to the top countries, then Luxembourg is at rank 1, Singapore is at rank 2. This means, say, Luxembourg is the number 1 country. It has the highest GDP per capita in 2010, and Singapore is at number 2 position, and so on. As I mentioned earlier, actually in 2010 Qatar was at the top rank, but it was eliminated from the list of countries because it had missing data in 1980. So if we look at these rankings, we can see that Congo has been going down. It started out at 121 position and it slipped to 127, and it has been bottom ranked in 2000 and 2010. And similarly for most of the poorer countries, they have been actually slipping down in ranks, and they have been becoming worse rather than better, except for Mozambique, which started out at the bottom rank in 1980 and has moved up by about 5 or 6 positions. But mostly we can see that the additional growth and the creation of wealth over the past 3 decades has not been very helpful or useful to the poor. Now if we look at the upper end of the spectrum, we see that Hong Kong has made a rapid increase. It was at rank 31 and now it has moved up to rank 5, and similarly Singapore was at rank 29 and it has moved up to rank 2. So both of these countries have done very well. So after doing this analysis, after looking at these numbers, one would want to go and see what were the reasons for the especially rapid rise of Singapore and Hong Kong. And basically it is statistics. The numbers provide us with clues to real world processes, and the statistics analysis is about finding out what these numbers mean in terms of the real world. This is a new interpretation of the subject. The traditional, the conventional, the Western interpretation, the statistician is supposed to confine himself to the numbers alone and do purely numerical work, and he is not concerned with the real world as such. But in fact, if we want to learn to make arguments with data, then we need to know a lot more about how these numbers relate to real world processes, and we need to know why is it that Hong Kong climbed up in ranks so rapidly in the past 30 years, and similarly for Singapore. And also we can learn something about why the growth processes which have been taking place have not had much effect on the fortunes of the poorer countries. As we have seen, making comparisons of GDP across countries requires making adjustments for population, for purchasing power, for currencies, and many other things. Similarly, ranks are not directly comparable across groups. Somebody who ranks third in a class of 10 students is not as good as somebody who ranks 10th in a class of 1,000. So making comparison across groups, it is more convenient to convert the rank into a percentile. A percentile is basically the ratio of the number of people that you beat over the size of the group. A formal definition can be given as follows, as is done in the slide. Suppose that the group size is n, then your rank is your position. N minus rank is the number of people that you beat. So you took the number of people that you beat or you did better than, and you divide by the size of the group. So the percentile is n minus rank over n. As a simple example, consider a class in which there are 5 students. So n is 5 and the scores are 70, 75, 85, 95 and 99 as listed in the slide. Then the score of 69 is at 0th percentile, because a score of 69 wouldn't beat anybody in this class. A score of 71 beats one person. So one person is 1 out of 5 persons, so your percentile rank is 20%. What about 70 itself? Well, here there is a little bit of an ambiguity. 70 can be considered as beating 0 people, or it can be considered as beating 1 person. So any number between 0% and 20% is a rank for 70. And actually there is a large number of different definitions of percentiles, and they pick different values here. We will consider any value between 0 and 20% as right rank for 70%. However, a midpoint would be also okay, so we could assign 70 a rank of 10 percentile, for example. Coming up to 75, then a number like 74 has a rank of 20 percentile because it beats 1 score out of 5. 75 itself is ambiguous as usual. 76 has a percentile rank of 40% because now you beat with a score of 76, you beat 2 people out of 5, and that's a 40%. So 75 will have any rank between 20th percentile and 40th percentile. Similarly, as we go up, 85 will have rank between 40 percentile and 60 percentile, and 95 will be between 60 and 80, and 99 will be between 80 and 100, and any number above 99 will have a 100 percentile rank. So with this percentile, the percentile number is comparable across groups. For different group sizes, the adjustment has been made for the group size. However, there are many other adjustments that need to be made to compare scores across groups. For example, if these are scores on the quiz, then different quizzes can have different amounts of toughness. The student groups can have different levels of brightness or preparedness, and there are many other factors which need to be taken account, which the percentile does not take into account. So again, making a comparison across groups is a very subjective procedure. Many factors need to be adjusted for. There is no clear objective way to make such comparisons. Nonetheless, we do make such comparisons across all the time, and these comparisons then appear to be objective because we're just comparing numbers, but actually they have a lot of subjective elements in them, as all comparisons do. The percentile graph is a very important concept in statistics, theoretical. It has a very fancy name. It's called the empirical cumulative distribution function. We will use it occasionally later on. It is a very simple concept. On the x-axis we put the scores, and on the y-axis we put the percentiles. This is the percentile graph for the same hypothetical scores data we looked at in the previous slide. There are 5 students in the course, and they have achieved scores of 70, 75, 85, 95 and 99. So if I look at this percentile graph, I see that the graph is flat at 0% from between 60 to 70, because all scores in this range beat 0% of the students. At 70 the graph has a jump, because a score of 70 can be considered as beating nobody, or it can be considered as beating one student, depending on whether 70 is greater than or equal to 70 or it's less than. So as we already discussed, so the graph jumps from 0% to 20% at 70, then it is flat up until 75, meaning that any score between 70 and 75 will beat 20% of the class, just one student. Whether you have 72 or 73 or 74, you will beat one student, and that will be 1 out of 5 students, and that's 20%. Again, at 75 score there is a 20% jump, because at 75 exactly it can be thought that you are beating one student for a 1 out of 5 or 20%, or you can be beating 2 students, and that's 2 out of 5, 45%. So the graph jumps from 20% to 40%, and then between 75 and 85 the graph is flat at 40%, because for any score in between 75 and 85, like 80, one is beating exactly 2 students out of 5 students, so one has a percentile score of exactly 40%. So in this way, the percentile score is what is sometimes called a staircase graph. It looks like a sequence of steps. It jumps up at the points at which there is a score, and then it stays flat between every 2 scores, and it starts at 0 and it ends up at 100%. So for a very high score, it beats all the scores, which is 100%, and for a very low score, it beats none of the scores, which is 0%, and in the middle the height of the graph is the percentage of the students that you are defeating, or you have a better score than. So this is a very simple graph. It contains a lot of important information, as we will see later. Coming back to our example of GDP per capita, here we have converted the income data into the percentile rank using the Excel function percentile rank or percent rank. The Excel function assigns 0 percentile to the top score and 100 percentile to the 0 percentile to the bottom score and 100 percentile to the top score. Now in 130 countries there will be 129 steps in going from the bottom to the top, so every step will receive a value of 1 over 129. So if we look at this table, in the last column, which is arranged according to sequence because it has been sorted on this last column, so every step will be of size 1 over 129, which is about 0.8% approximately. And so every step is of size 0.8%. In the earlier columns, they are not in order because they haven't. The sorting has been done according to 2010, and so basically these columns convey the same information that we had earlier. As we can see that the poorer countries have slipped in rank mostly, Madagascar being the only exception which increased its rank. Sorry, not Madagascar. Madagascar did slip in rank also. Rather it was Mozambique which went from 0th percentile, the very bottom, to 4.6 percentile, which is not too respectable either. But anyway, among the richer countries, again the same patterns are observable. We can see that the UAE was at rank 100 percentile, which means it was the top ranked country for the 1980, 1990 and 2000, but slipped a little bit in 2010. Now this is worth investigating, whether it slipped because of an increase in population or whether it was due to a decline in oil revenues. Similarly, we can see that Singapore has done very well. It went from 78th percentile to 99th percentile, and similarly Hong Kong has done very well. Other countries have been relatively stable in percentile rank. Now actually this particular example is not very useful illustration of the value of percentiles, because we are comparing across years, and the size of the group has been roughly stable across the years. It has been the same set of countries which we are comparing, and so the percentile is meant to adjust for the size of the group. So it would be more useful in a situation where the size of the group was changing. Here, because the group size has been the same, so the percentile information and the rank information is roughly the same, and we learn roughly the same kinds of things from the percentile table as we do from the rank table. In this slide we look at the percentile graph for the GDP data to learn how to read such graphs. If you look at this graph, you see that it is rising very fast in the initial part and becomes much flatter in the later part. If you remember that each country adds a constant jump of about 0.8%. So when the graph is rising sharply, that means that there are a lot of countries, because there are a lot of jumps. If the graph is rising slowly, that means that there are very few countries. So once we understand this, we realize that there are very few countries which are rich and there are a lot of countries which are poor. If you look at the halfway point is about where the 50th percentile is. It's not so easy to read from the graph, but if you look at the data, it's around 8,400, a little bit below 10,000. The value of 10,000, at 10,000 the graph is about 55 percentile. So 50th percentile is a very important number. That's called the median. So about $8,400 per year per capita is the median number. Median means that half of the data is below this number and half is above this number. So half of the countries are very poor with 8,400 or less, and half of the countries have more than this amount. So the median is one of the important percentiles, and similarly you can divide the data into 4 parts and look at the 25th percentile. That's called the first quartile. The second quartile is 50% and the third quartile is at 75%. So looking at this percentile graph, we can tell that for example, the income of Pakistan is 2,397 looking at the original chart, and 2,397 occurs near the beginning, so it would be very hard to read off this graph, but it's around 25th percentile. So Pakistan is about in the 25th percentile of the data, which means that a quarter of the countries are below and 3/4 of the countries are above Pakistan. So similarly, by using this graph we can figure out what percentage of the countries are below the country and what percentages are above. This can be quite important information in many contexts. Percentiles are often used to create groupings. So the top quarter, the second quarter, third and fourth, these can be given qualitative names. For example, if we take the top 10% countries, these are the countries which have 90th percentile or above. We could call these the rich countries. So there are many ways. One common methodology is to use quintiles. Quintiles are fifths. So we divide the countries into the bottom 20%. These are the poorest countries, and then from 20% to 40%, these are the poor countries, and then 40 to 60%, these would be the middle countries, middle income or median income, and then 60 to 80% these would be the richer countries, and the top 20% would be the richest countries. So there are many ways to categorize, and these are all qualitative, and these are not objective, but once they are backed up by numbers and definitions, they give the appearance of objectivity. Okay, we now just review some of the technical terms that were introduced in this lecture. After sorting the list, you can find the minimum and the maximum, and the range is the distance between the minimum and the maximum of the data. Also, after sorting, it becomes easy to assign ranks to the data. The ranking is just the ordering. The first ranked is the top and the bottom ranked is the worst. The ranks are assigned out of the total population. So somebody is fifth out of a population of 200, etc. The percentiles are used to basically divide the rank by the total population size. So the percentile measures the proportion of the population which is ranked lesser than a given number. Median is the 50th percentile, which means half of the data is ranked below and half of the data is ranked above. Quartiles divide the data into 4 groups. The first quartile is 1/4 of the data. The second quartile contains half of the data, so that's the same as the median. The third quartile contains 3/4 of the data, and the fourth quartile is of course all of the data. Quintiles divides the data into 5 portions and works the same way, with the first quintile being 20% and the second being at 40%. There is a new term that I will introduce here that's called the interquartile range. That is the distance between the first quartile and the third quartile. This will be useful later on as a measure of the spread of the data. You will be assigned exercises to give you practice on the use and the calculation of these numbers on a practice data set. Finally, we conclude this lecture by remembering the main theme of this course, and that is learning how to make arguments with numbers. When we compare numbers, we are always trying to prove the superiority of something or the inferiority of the other thing, and on the face of it, on the surface, this seems like a simple matter. We just look at 2 numbers and we decide which one is higher. But in fact, as we have seen, there is a lot of complication hidden behind the scenes that depends on how these numbers are interpreted. As the initial story illustrates, if I want to take a number, for example, we take the GNP of Pakistan and we ask, is Pakistan doing well with respect to its GDP? So if we look at all the countries, then Pakistan is in 25th percentile, so it's doing badly compared to 75%. On the other hand, we can change the benchmark. We can say, let's just look at Asian countries, or let's just look at countries with large population. So if we change the reference group, then we can change the comparison. Similarly, we can change the benchmark. Who are we comparing Pakistan with? We can exclude a lot of countries, saying that those countries are different from Pakistan in some characteristic or the other, so they should not be included in the comparison group. So all of these are tactics and strategies to make the comparisons come out differently. Even more radical methodology is to not agree to the criteria being used to measure. We can say that, well, we don't agree that the GDP should be used to measure the wealth of nations. The wealth of nations depends on other things, like, for example, we can say, let's look at the divorce rate, let's look at the suicide rate, let's look at the rate of mental illness or crimes. So there are many different kinds of criteria, and if we want to argue that A is better than B, we can dispute the numbers for a given criteria, or we can change the criteria. There are many rhetorical strategies which are used and which can be used, and the statistical strategy is to give the illusion of objectivity using hard numbers, but the object of this course is to show you that behind those numbers there is a lot of arbitrary decisions and subjective decisions which control which numbers are to be used. So in our goal in this course will be to learn how to use these arbitrary decisions to make comparisons go in the direction that we want them to, and also perhaps to learn something more about the reality. Can we say something about what is the true comparison? It's quite difficult, but sometimes it is possible. We end this lecture by making dua to Allah to accept our efforts and struggles and to guide us to the haqq, because the truth is not accessible except when Allah Ta'ala wills it for us.